Okay, hello and welcome to this weather revision video for National 5. So in this weather revision video, we're hoping just to recap some of the key points that you need to know for your exam so that hopefully you can use your notes and this revision guide to help with your studying. So the first topic we are going to look at are the factors that are affecting temperature. Okay, so this is a question that comes up fairly regularly, and when we are studying this, there is a little acronym that's helpful to remember, and that is LARD. Okay, so LARD is what we're looking to remember if you see the question of the different factors that affect temperature. Now, if we look at this map on the right hand side, you can quite clearly see that temperatures are much warmer in the south of the country, and as you move further north they become colder. So there are a few different reasons for that, which we're going to explain now, and then we'll give you a few key terms to remember for your revision. So when we're discussing latitude, latitude is essentially the lines that are horizontal on the map. Now, these lines are going to indicate how close or far away you are from the equator. Now, obviously, the closer you are to the equator, the warmer it's going to be, and the further away you are from the equator, the colder it's going to be. And this is to do with the sun's rays that are coming towards the Earth. When they strike the Earth near the equator, they have a very kind of an intense heating effect over a relatively small area, and they also have less atmosphere to move through as well. So the insolation, that incoming solar radiation that is coming off the sun, is able to make equatorial regions much warmer. The polar regions are going to receive the same amount of insolation. However, because the Earth is curved near the poles, this insolation is spread out over a much larger area, and the also has a thicker atmosphere to pass through as well, or more atmosphere to pass through. So combined with the larger area the insolation has to cover and the larger amount of atmosphere it has to pass through, there is essentially less heat that makes it to the polar regions. So for that reason, there is a surplus of energy at the equator and a deficit of energy at the poles. So we can see this by looking at our little map here. The closer you are to the equator, aka south of the United Kingdom, it's going to be warmer, and the further north you get, it's going to be colder. Now, when we talk about aspect, this changes slightly, because this is all to do with what direction your land is facing. So if you imagine a little 3D mountain now emerging, let's say in the Highlands of Scotland, when the sun rises in the east, the sun is going to shine on the eastern side of the mountain, therefore giving it some sunlight. When the sun moves throughout the day, it's going to travel from east to west, and because the sun is going to be below us in the UK, it's going to give insolation to the southern side of the mountain during the day. And then as the sun is setting, it's going to give insolation to the western side of the mountain. However, the northern side of that mountain may never see sunlight at all. Okay, so this is why we often describe corries as snow falls and collects in a north facing hollow. It's because those areas generally do not get sunlight, and therefore they're much colder, and it allows snow to accumulate into sufficient quantities to start to gouge out the landscape and form that corrie. So when we talk about aspect, it's southern facing areas that are getting more sunlight throughout the day, and therefore they're warmer. For relief, we are talking about climbing up that mountain. Now, it's no surprise to anyone that's climbed the mountain before, it is always going to be colder at the top of the mountain than it is at the bottom. And this is to do with the air getting a little bit thinner as you move up. The atoms have more space kind of move around, and therefore there's more kind of heat lost. So the closer you are to the ground, the warmer it's going to be, and the higher up you go, the colder it's going to be. Now on average, they say for every 100 meters you ascend upwards into the atmosphere, or upwards, you're up your mountain, you are going to drop 1 degree Celsius on average. So that's your key term to remember for this one. Finally, you have distance to the sea. Now, distance to the sea can be quite complicated. However, if you keep it simple, it shouldn't be too bad. In the summer months, we know that the UK is going to experience some sunshine. Obviously, we'll have some rain as well, but generally in the summer months, the sun is closer to us. It's near the Tropic of Cancer, and therefore we're going to have more insolation. Now, in the summertime, that insolation is going to cause the land to heat up very quickly because it's a solid. However, it's not going to have that much effect on the water because water takes a lot longer time to warm up. So the water will always be relatively cool. So even if the land is very warm in the summertime, the water will be relatively cool, which is why coastal areas will be cooler in the summertime. If we're to think about the winter time, the sun is at the Tropic of Capricorn. It's much further away from us. We're having less insolation. Therefore, the land will be much cooler. The ocean, on the other hand, in the wintertime, is still relatively warm. Remember, our water is coming up from the Gulf of Mexico across the Atlantic Ocean, known as that North Atlantic Drift. So the water will still be relatively warm near our coastal regions, even if it's much colder on land. So the key thing to remember for this one, whether it's summertime or wintertime, the temperatures will always be milder near the coast due to the effect of the North Atlantic Drift. So here is that sample question that we were looking at, and this is how I come up this particular year. Looking at the diagram, explain the factors which cause differences in average UK temperatures. Now, it doesn't say to make reference to the diagram, which some people did this year and then lost some marks. It's literally just looking for you to explain what causes the differences in the average UK temperature. So you don't need to make reference to this diagram. It's just there as a guide to try and help you out. Now, the key things we want you to say when answering this question, if you want to summarize what I just explained into kind of 4 points, would be your L, latitude. The closer you are to the equator, the warmer it will be. The further away from the equator, the colder it will be. A, aspect. South-facing areas receive more insolation, therefore they are warmer. Or relief. The higher you go, the colder it will get. On average, it gets 1 degree colder for every 100 meters. D, distance to the sea. The closer you are to the sea, the milder the temperatures will be year-round due to the effects of the North Atlantic Drift. The next topic we're going to look at are the factors that affect rainfall. Now, this question is much less frequently asked. However, it's still one that you need to know for your exam. When we're talking about factors affecting rainfall, we're essentially asking what is causing rainfall to occur. As you can see in this diagram, the dark blue areas are where we have the most rainfall, and the green areas are where we have the least amount of rainfall. Now, obviously, all of the UK is going to receive rainfall, but we can clearly see in Scotland the dark blue patches where there is over 2,000 millimeters of rainfall. We'll also notice that there is probably a link to the prevailing winds, as you can see in this diagram. Now, for this answer, there is another acronym to remember, and that is RAD, or AD. Now, for RAD, you'll notice there are only 3 bullet points, which means you might have to give more than 1 point for each of these in order to obtain full marks in your exam. You'll also notice that the words are the same as in the previous previous question. However, they do have a different meaning in factors affecting rainfall. So please remember, if you're studying lard in the previous question, the words might be the same, but there will be a different meaning for this question. When we're looking at this diagram, you can see essentially what's happening. We have warm, moist air moving in from the Gulf of Mexico across the Atlantic Ocean, known as the North Atlantic Drift. That warm air is able to carry a lot of moisture towards the UK. Now, as that warm, moist air meets a mountain, it is unable to go around the mountain or through the mountain, so it must go over the mountain. And we know that when the warm, moist air is forced upwards, the air is going to cool down, because as you go up into the atmosphere, it is going to get colder. Now, when your warm, moist air is cooled, it's going to condense and it's going to form clouds, which is why when we look at this diagram, we can see rain clouds at the top of the mountain. This is also why on the western coast of Scotland, we have more rain. It's due to the North Atlantic Drift coming from the west, and it's also because we have the highlands on the western side of Scotland. So collectively, they are going to be generating their own rain, essentially. Now, as the air passes over the mountains, it's able to sink back down again, and essentially as it sinks, it's going to become warmer, which is why there will be a rain shadow on the eastern side of the diagram here. So another way to think about this might be that on the western side of Scotland, where Glasgow is, we're going to have warm, moist air moving in, so there should get more rainfall. And as that rain kind of precipitates out over the land and sinks back down, it's going to get drier and a little bit warmer, which is why the eastern side of Scotland, let's think Aberdeen, might be a little bit drier than the western side. If you're looking for a sample answer for factors affecting rainfall, this might be one that we can look at. So relief is when upland areas receive more rainfall than the lowland areas. Aspect will look at the hillsides that face the moist winds receive the most rain. In the UK, these are the west-facing slopes because the Atlantic Ocean is to the west. Distance from the sea. Winds that reach the west coast are full of water vapour and bring lots of rain. As they move eastwards, they drop most of their water, so bring less rain to places further east. You might also want to mention there the North Atlantic Drift. That is where those warm, moist winds are coming from. Now, this question is fairly straightforward, but what you need to remember are the names for the different air masses. Now, this can be easily done by remembering where the air masses are coming from and what they're passing over. In this diagram, you can see the air masses on the left-hand side all have to pass over an ocean, and therefore they are labelled maritime. On the right-hand side of this diagram, we have air masses coming from the continent, so they are called continental. When they come from the south towards the UK, they are bringing warm weather with them. When they come from the east and west, they are going to be bringing polar weather with them. And when they come directly from the north, that is going to be your Arctic weather coming with it. Now, when we have maritime air masses, they're going to bring a lot of moisture to the UK. So we could expect rain, snow, and sleet. Continental air masses are usually much drier. For temperature, we can think of tropical areas being warmer, polar areas being cooler, and Arctic regions being cold. Now, when we put that information together, you have a diagram that looks something like this. Now, it's important to know where your air mass is coming from and what weather conditions will likely come with it. It's also important to know the names of your air masses, as these questions have been asked before, to simply label the diagram, and they'll have some of the air masses emitted. You just need to give the name. Here is a typical past paper question that is related to air masses. In this particular question, it's asking, describe how a prolonged spell with a tropical continental air mass in summer would affect the people of the British Isles. And it's 4 marks. Now for this question, you should be thinking, okay, tropical continental air mass. When a tropical continental air mass is moving towards the UK or over the UK, it's tropical, so it should be warm, and it's continental, so it should be dry. And typically, when we have these tropical continental air masses moving over the UK, they can come from as far as the Sahara Desert all over Europe towards the UK. And they will bring conditions similar to a heat wave. So, for this question, we're describing what a heat wave would be like for the people of the British Isles. Now this, once again, is a very nice question because you can say almost anything that is relevant during a heat wave. Some typical answers that are popular are ice cream sales may increase as there are more people trying to cool off in the warm weather. Coastal towns may become more congested as people wish to travel to the beach. Sunburns may be common as people spend too much time in the sun without sunscreen. The NHS may have more patients suffering from sunstroke due to sun exposure. There may be a hosepipe ban due to water levels in reservoirs dropping. Farmers' crops may wither and die, meaning he will lose money. Farmers may have to invest in irrigation systems to ensure their crops are watered in the future. There may be other points which you wish to include for this question, but again, anything that you have seen in the news or heard that is relevant and true should be accepted as an answer for this question relating to a heat wave. The other question you'll typically get asked when you see an air mass question will be the effects of a polar continental air mass. Now for a polar continental air mass, you'll be thinking polar should be cold. However, you have to be very careful that the question specifies is it summertime or wintertime. Because in summertime, a polar continental air mass will still be warm and dry. However, if it's a winter polar continental air mass, then you can expect it to bring cold conditions. Now, although it says continental, you'd expect it to be dry, but sometimes the polar continental air mass in wintertime can bring snow and sleet and icy conditions along with it, carried from Siberia and Russia. If you get a question that states, describe how a prolonged spell with a polar continental air mass in winter would affect the people of the British Isles, here are some popular responses. Schools may have to close, meaning students get a day off to play in the snow. Supermarket shelves may run empty as people buy and deliveries cannot get into stores. There may be a shortage in gas supplies as people stay at home with their heating on. Road accidents are common as people try to get to work, but the road conditions are too icy or too slippy. The military may have to be called in order to get key workers to their jobs, for example, doctors and nurses. Pipes may freeze, causing damage to homes, meaning insurance companies will have to pay out more money. People may be trapped at airports or train stations as services are cancelled or delayed. And again, there are a range of answers you can give for a polar continental air mass depending on the situation that you may have heard of before. Again, if you've seen something in the news or heard something that's relevant to a very intense cold snap, you'll probably be able to get marks for this one as well. Our next topic is weather station circles. Weather station circles are a very nice question to get asked, and it has come up before where you've been asked to draw a weather station circle or to read a weather station circle. Here are the key components. The circle itself will tell you about the cloud cover. You have a maximum of 8 octaves of cloud cover, and the circle can be divided into segments, which we'll discuss more in a moment. Outside of the circle, you will see a number. This is the temperature, and it is measured in degrees Celsius. Also outside the circle, you'll see the present weather. This symbol will change depending on the present weather being discussed. You will also see a line coming out of your circle, and this is for wind direction. The line will always point in the direction that the wind is coming from. On this line, you will see more lines. These lines are there to tell you about the wind speed. Long lines indicate 10 knots of wind, short lines indicate 5 knots of wind, and you can simply add them up. So in this situation, there is 25 knots of wind. Sticking with wind, we can see on the right-hand side of this diagram, if there is no line coming out of your weather station circle, we can consider the weather conditions to be calm with an additional circle around it. So additional circle around your weather station circle indicates calm weather conditions or calm winds. A line coming out by itself is 1 to 2 knots of wind speed. A line with a small notch on the end is your 5 knots. Large notch is 10 knots, and again you can add them up as you can see in the diagram here. The key thing to remember is that you cannot go over 50 knots of wind speed with your small tick marks. Anything above 50 will be the little triangle that you can see present on the end of this weather station circle. As we move to the middle column, we can see our octaves. And as we mentioned, octaves go from essentially clear sky, 0 octaves, all the way to 8 octaves. And you need to remember these symbols. So one line down the middle is 1 octave. A quarter of the circle, which is a quarter of 8, is 2 octaves. For 3, you have a quarter and an additional line. For 4, you have half of 8, so it's half a circle. For 5, you have your half circle plus that additional line. For 6, 3/4 of 8, so 3/4 of a circle. And for 7, you have almost a full circle, but there's going to be a gap in the middle of some kind. And then obviously for 8, full circle, you're going to have your full circle shaded in there. Now, if the sky is obscured, you will have an X in the circle. This relates to potentially something blocking the instrument that is measuring cloud cover. On the left-hand side, you can see your different types of weather conditions that may be present. So these can be put together to make more complicated ones, which we'll discuss in a second. So the comma that you can see is drizzle. The upside down triangle is a shower. The full stop is rain. A star represents snow. The triangle itself is hail. This strange looking shape is a thunderstorm. 3 dots, heavy rain. A dot and a a dot and a star is essentially rain and snow, which is sleet. Your snow shower there is snow symbol, and your shower, your upside down triangle, so you can combine them together to show what a snow shower would look like. 2 lines is going to be mist, and 3 lines is going to be fog. So please keep in mind that these symbols may be combined in order to tell kind of more detail about the present weather. Again, there's no easy way of learning the symbols. There's no common patterns. You just need to know each individual icon. Our next section is anticyclones, and these are high pressure zones. So when you have an anticyclone, you should be envisioning air coming down from the upper atmosphere towards the Earth's surface. And as it comes down, all those air molecules are being pushed down. So you can imagine the high pressure on your shoulders, which makes your anticyclone your high pressure zone. Some of the common features of an anticyclone will be that the winds blow clockwise and outwards in an anticyclone. So again, if you look at this diagram and imagine the air coming down from the upper atmosphere, of course it's going to spread outwards as it reaches the ground surface. It has nowhere else to go. And it's going to spin clockwise, as you can see in the arrows here. So it's clockwise direction. In an anticyclone, your isobars are going to be widely spaced. Now, when there's a wide distance between your isobars, this means there's going to be light winds. Similar to your contour lines when you talk about mapping, when your contour lines are close together, it's going to show a steep incline or a steep gradient. When they're far apart, it shows flat land. Isobars do something similar. When they are far apart, it's going to show calm winds. When they're close together, it's going to show very strong winds. In an anticyclone, we're going to have dry weather with few clouds because the air is sinking. So because no air is rising up into the atmosphere, it cannot cool, it cannot condense, it cannot make rain clouds. The air in an anticyclone is sinking. And as air is sinking, it's only going to get warmer and spread outwards as it reaches the Earth's surface, so there is no opportunity for clouds to form in an anticyclone for the most part. Anticyclones move quite slowly, so they will give settled weather for a long period of time. So here are the weather conditions that you will experience in an anticyclone in the summertime and in the wintertime. Now this is quite a popular question as well, and if you're able to remember this little table, this contains the keywords that we would like you to make reference to if a question like this were to emerge. So the aspects we're looking at are the present weather, the precipitation, the winds, what the daytime temperatures are like, what the nighttime temperatures are like, and what we might see in the morning time. So I would recommend writing down this little table and keeping it somewhere and making reference to it, and it'll make more sense when we give you the sample answers on the next slide. So here is our anticyclone in the summertime. Now we know it will be sunny because the air is sinking in an anticyclone, meaning the skies are clear. It is dry in the summertime because sinking air means no clouds are forming and therefore no precipitation. There are light calm winds because the isobars are always widely spread apart in an anticyclone. There are hot temperatures during the day because the sun is at the Tropic of Cancer, meaning high insolation. Again, that word insolation, incoming, solar, radiation. And the Tropic of Cancer is the band at which the sun gets closest to the UK. It is very cool during the night because there are no clouds to stop the heat escaping. So you can envision the clouds being like a blanket which prevents the heat being lost to space. The heat will come off the earth at nighttime, be radiated back out. If clouds are present, those clouds are going to block the heat and keep it near the surface. But if there are no clouds present, any heat that the earth absorbs during the day is going to be released back out to space at nighttime. Early morning dew is very common due to cooler air at night not being able to hold as much moisture as it can during the day. So it precipitates out on the surfaces as water droplets. Now again, this is probably easiest to remember if you envision the air inside your bedroom perhaps. If your heating is on at nighttime or the evening time, you will not see any moisture on your windows. That's because warm air is holding moisture in your room. However, at nighttime when your heating is switched off, when you're wrapped up in bed, the air temperature will start to drop and all the moisture that is held in your air is going to condense on any nearby cold surfaces, which is likely to be on your windows. So if you see water on your windows when you wake up, that's because the air has essentially precipitated out all the moisture onto the nearest cold surface. And the same thing happens in nature. When the warm air during the day is heated up, at nighttime when the air cools down rapidly, the air cannot hold the moisture, so all that moisture is going to condense onto any nearby surfaces, which is why you might see dew on grass or on bushes. Now we're going to look at an anticyclone in the winter time, and you'll see the first three sentences are exactly the same. It is sunny because air is sinking in an anticyclone, meaning skies are clear. It is dry because sinking air means no clouds are forming and there's no precipitation. There are light calm winds because the isobars are widely spaced apart. So far we've seen those questions are exactly the same. Those answers, three sentences, exactly the same as the previous one. They're both uniform for both. Now we're going to see some slight changes. It is very cold during the day due to the sun being in the Tropic of Capricorn. Therefore, reduced insolation. So this is really just explaining the sun is now in the southern hemisphere. It's far away from the UK at the Tropic of Capricorn, which is why it's going to be very cold during the day. Even though the sun is out, and even though the sun might be shining on the land surface, there's less insolation actually heating up the air or the air surface because the sun has much more atmosphere to pass through. There is frost or freezing conditions at night because there are few clouds to keep the heat in. Early morning fog is very common due to the cold ground cooling the air, so the moisture within the air condenses. So in this one, essentially, once again, as that air is passing over the freezing cold ground, it gives it a chill and all the air precipitates out, all the moisture in the air precipitates out almost instantly, condensing, making fog. So it's like walking around in a cloud. That's your fog. And it's the same idea where your warm air cannot, your cool air, cannot hold as much moisture as your warm air during the day, so you're going to have fog forming in winter time. Here is a past paper question explaining the reasons for the weather conditions at Bathgate on the 28th of December. Now, in these questions, they're not going to tell you describe an anticyclone in summer or winter. You have to work that out for yourself. So hopefully here you have seen 28th of December and you've realized it is a winter anticyclone. The other key word here is give reasons, meaning they're looking for an explanation. Now, in this particular question, they want you to apply your knowledge of anticyclones in wintertime to this weather station circle. Again, a weather station circle, should give you 5 points of information. So we're going to use all 5 points. The first one that I see is 1 octave cloud cover. This is because air is sinking in an anticyclone, meaning clouds are not forming. The present weather is sunny. So we see in the diagram there's actually no symbols. Remember, no symbol means sunny. The present weather is sunny. This is because the lack of clouds means there is nothing to impede sunlight from reaching the ground surface. The wind direction is from the west. This is because winds move clockwise in an anticyclone. It is -2 degrees because it is December. The sun is at the Tropic of Capricorn, meaning there's less insolation in the UK. You could also say there are no clouds to trap the heat, which means it gets colder at nighttime. There is 5 knots of wind speed. This is due to the isobars being spaced far apart. Now that will give you your explanation and your 5 marks worth for this question. But again, it's very important that you memorize that little diagram, the little table at the beginning, which gives you the key words for an anticyclone in summertime and wintertime, because that is almost like a little cheat sheet that you can always reference back to so you make sure you're not missing anything to discuss. Our final section is going to be based on depressions. And depressions are low pressure zones. This is where air is moving towards a low pressure zone on the Earth's surface. So imagine the air being sucked into one location, and once it reaches that location, that low pressure zone, it's being pulled upwards into the atmosphere, high into the atmosphere. And you should know that when air is being pulled up into the atmosphere, that allows for it to cool and condense, and it's going to give us rainy weather conditions. So we're going to expect different types of rain when we have a depression. Here are some of the key features of a depression. You'll notice your isobars will likely be closer together, which means there will be stronger winds. You'll notice that the wind direction moves in an anti-clockwise pattern around your low pressure zone. So remember, anticyclone, clockwise, depression, anti-clockwise. So don't put your two antis together. You'll also notice there are some extra symbols on this map. You'll see some red semicircles. These are your warm fronts. And you'll see some blue triangles. These are your cold fronts. Now, you will not always have colour in the exam to indicate warm fronts from cold fronts. So you'll need to remember the symbol of a semicircle is almost like a rising sun, which helps me remember that it's a warm front. The little triangles look a bit like icicles, which helps me remember that it's a cold front. When you have the section that is blue triangles and red semicircles, this is called your occluded front. And it essentially occurs when the two fronts catch up with each other, and they're going to give lots of rain in those areas as well. The key thing to remember when we're talking about depressions is that the UK is usually always in a cold air sector. But we're very close to the boundary with a warm air sector, which usually covers Spain and part of France. And occasionally, we can get a wedge of warm air that is pulled up from France or Spain, and it will essentially form a little triangle or a little wedge of warm air in our cold air sector. Now, when this occurs, The cold air sector is essentially not very happy, and the cold air sector is going to do everything it can to lift that warm air that's intruded on its space up and out into the atmosphere. Obviously, it can never achieve this permanently, but it can get rid of the warm air and essentially revert the area altogether back to a cold air zone. So in this diagram, we can see number 1 is the cold air zone, and number 3 is this wedge of warm air that is intruded into our usual cold air zone. Now, where the warm air is touching the cold air, we have our fronts forming. So the leading edge of the warm front is our little semicircles. That's showing the front of your warm air wedge. And where the warm air in stage 3 and the cold air in stage 1 are touching, we have the boundary, which is called the warm front, which is labelled 2 on this diagram. When the warm air and the cold air are meeting each other, they're going to create a band of clouds. So along that warm front, we're going to have rain. The same is true at stage 4. Stage 4 is showing the cold front. And this is where the cold air sector, it has come in behind this warm wedge of air, and it's trying to lift stage 3 up and away. So stage 4 is your cold air coming back in around it, and again, where your leading edge of the cold air is touching your warm air, they're not going to mix very well, and they're going to cause another big band of rain clouds to form. This little video is quite helpful in visualizing what I've just explained, so I'm going to play this for you now so that you can understand a little bit better.
Frontal rain has to do with one of these things. It's a depression, one of the most common features on UK weather maps. The lines and symbols don't really give much of an idea of how it's formed or what it's doing, so here's World Physical's simplified step-by-step guide to what happens. The UK lies on the boundary between cool air from the Arctic and warm air from the humid tropics. The boundary moves around according to the time of year and the prevailing weather conditions. There's one kind of move on the boundary, though, that actually kicks off at a depression. It's when a wedge of warm air forces its way into the cold. The wedge is shown like this on a weather map. The two lines mark the boundary between the warm air and the cold air. They're known as fronts. The wedge, or depression, is moving all the time. Most of the ones that affect the UK move from west to east. The leading front is known as the warm front because it has warm air behind it. The second line is called the cold front because it has cold air behind it. Along both fronts, warm, humid air is cooled by contact with the cold air. The water vapour in it is condensed into moisture and falls as rain. This means we get two bands of rain as a depression moves through. These usually take between 1 and 3 days to pass over, and the UK is affected by around 100 of them every year.
Okay, so there we had that little video, and hopefully that was able to visualize a little bit better for you what's actually going on when a depression is passing over the UK. Now, once again, here is a little map showing a depression, and just to get this clear in our minds, we're going to discuss this in 5 stages. Now, your examiner will not be familiar with the 5-stage idea potentially, so you still have to remember the name for each of these areas. What I will refer to as stage 1 on this diagram is going to be your cold air sector. So this is the sector of cold air. When we see stage 2, this is your warm front. It's the leading edge, it's your warm front. Stage 3 is your warm air sector. Stage 4 is your cold front. And stage 5 is your cold air sector once again. So we'll see stage 1 and stage 5, they are obviously all connected, so it's the cold air sector. Stage 3 is your warm air sector, and then your leading edges are going to be your fronts. So your warm front is where the cold air and warm air touches, and your cold front is where that cold air from behind is touching your warm air once again. Now in this diagram, you can see the same stages, but now we're looking at it as a cross section. So at stage 1, you can see we're still in the cold air sector, but warm air is less dense. So it's risen up over the cold air sector, and where that warm air is touching the cold air, you can see a variety of clouds forming. But at the very beginning, so still at stage 1, we can see high in the sky your cirrus clouds, those high wispy clouds. And they will not bring you very much moisture at all. At stage 2, closer to the ground, we can see the warm air sector and the cold air sector having much more contact. And here we have nimbostratus clouds. These nimbostratus clouds will give you drizzle or steady rainfall. Once the warm front passes over, those nimbostratus clouds don't just disappear, they're going to break up and form individual stratus clouds. Now those stratus clouds are quite scattered in the sky, so it kind of depends if you're going to get rain or not if you're underneath some of these stratus clouds. So you could say chance of rain or chance of drizzle. Where we have stage 4, we have our cold front. Cold air is very dense, which is why it comes in much more aggressively, a bit like a bulldozer. It's really pushing in hard and trying to lift that warm air sector away. And because there's much more surface area for the warm air and cold air to be in contact, they create large cumulonimbus clouds. And those are going to give you very heavy rainfall. Once we get to stage 5, you'll see, once again, these tall cumulonimbus clouds will not just disappear, they're going to break up into smaller cumulus clouds, which once again will give you scattered showers. So it depends on where you are. If you're under a cumulus cloud in stage 5, you might get some rain, but you might avoid them also. So scattered showers there for stage 5. You'll also notice in this diagram that there is a colour difference based around temperature. So stages 1 and 5 are obviously cold air sectors. Now their temperature is going to be a little bit cooler. In the centre, at stage 3, we have a warm air sector. That's that wedge of warm air that was pulled up from the warmer regions around Spain, France, etc. Now, when we call it a warm air sector, it is warmer, but not drastically. We're talking potentially a couple of degrees where it might be slightly warmer. On your boundaries, or your fronts, stages 2 and stages 4, these areas are zones of transition where there will be cooling occurring at stage 4 because we're moving from a warm air sector to a cold air sector. And there'll be warming at stage 2 because we're moving from a cold air sector to a warm air sector. It's important to keep this in mind whenever you're giving your answers. The best way to remember the 5 stages of a depression is once again by memorizing this little table. This table will be able to give you the best chance of your getting your optimum results. Because regardless of the question you're asked, if you remember this table, you'll have the keywords that the examiner is looking for you to discuss. So once again, at stage 1, we have cirrus clouds that are high and wispy in the atmosphere. They are going to bring no rain. In cold air, the pressure is relatively high. So think of all those cold atoms densely packed together, giving a high pressure. And the temperature is obviously cold. You're in a cold air sector, temperature is cold. In stage 2, we're now at that zone of transition. We're at the warm front boundary. And we have nimbostratus clouds forming here, that band of stratus clouds, nimbostratus clouds, band of stratus. And where you have your nimbostratus clouds, they are going to bring drizzle or rainfall. The pressure is going to be decreasing because we're in that zone of transition. So we're going to be moving from a high pressure zone where the air is cold to a low pressure zone where the air is warm. And we can say the same for the temperature. The temperature is warming as we move from a cold air sector into a warm air sector. Stage 3 shows you stratus clouds. This is once again because the band of nimbostratus clouds has broken up, so we're left with stratus clouds by themselves. They will give you a chance of drizzle or a chance of rain. Again, it depends on where the clouds are, but that's perfectly adequate to say chance of drizzle or rain. Pressure is low in a warm air sector, and the temperature is warm, again because you're in a warm air sector. At stage 4, we're back at a zone of transition. We have our cold front bulldozing in, lots of contact or surface area to meet with the warm air zone. So it's going to form cumulonimbus clouds, which are going to give you heavy rain. The pressure is going to be increasing because we're moving from a warm air zone where those air molecules are free to move around a little bit more rapidly because they're warm, back to a cold air zone where the molecules are a little bit slower and a little bit more densely packed. And again, this is going to result in an increasing pressure. Temperature once again will now be cooling as we move from the warm air sector to the cold air sector. In stage 5, we're going to have the remnants of the clouds of stage 4. So those big cumulonimbus clouds are going to break up. So in stage 5, we have cumulus clouds. And they're going to give you scattered showers depending on where they fall out. And again, it's because their big band of cloud is broken up into individual clouds. The temperature once again is back to cold, and essentially we're back where we started then. Okay, so that's your depression has then passed over. So remember, when your depression is passing over, they are going to go through each area of the UK, will go through all 5 of these stages. So stage 1, stage 2, stage 3, stage 4, stage 5. And this again will happen time and time again. As I said in the video, these pass over the UK about 100 times a year, and they take about 1 to 3 days to pass as well. Now this table, once again, is very, very handy as a quick reference whenever you're looking to see what a question might be. For these particular questions, these are what we call A-band questions, and they're designed for students to see if we can get them A's. So these are really, really tricky sometimes. And the questions are always varied. There'll be different synoptic charts being used. There'll be different weather stations being used. So we cannot give you a sample answer per se for this question. However, if you know this table, you should be able to answer any question that comes up. Here is one of those sample questions, and it says, study the synoptic chart and the synoptic symbols in the diagram. Give reasons for the differences in weather conditions between Ballycastle and Limerick. Now, for this question, the key word that should be giving you alarm bells should be differences. When you hear the word differences, you must make a direct comparison between the two things being discussed. Another keyword is give reasons, which means you also must give an explanation. So for this diagram, we are going to look at our weather station circles. We're going to pick out the 5 bits of information that we can obtain from a weather station circle, and we're going to compare them between Ballycastle in Northern Ireland and Limerick, which is up in Shetlands. The first thing I'm going to draw attention to is the cloud cover. So in my sentence, I would say, there are 8 octaves of cloud cover in Ballycastle, whereas there is 1 octave of cloud cover in Limerick. That is me making my direct comparison. I still need to give my reason though. So my reason would be, the reason for 8 octaves of cloud cover in Ballycastle is due to the cold front approaching. Here, the warm air and cold air will create cumulonimbus clouds, which will cover the sky. There are no fronts present, however, in Limerick, which would explain the 1 octave of cloud cover. And that is my first point completed. Now, it's quite a big point, I understand, but you have to make comparisons or you will not get the marks. My next point would be the wind direction. The wind is coming from the northwest in Ballycastle, whereas the wind is coming from the southeast in Limerick. This is because air moves anti-clockwise in a depression. My next point would be the present weather. The present weather in Ballycastle is heavy rain, whereas the present weather in Limerick is clear skies or sunny. This is because there are no fronts near Limerick. However, the cold front in Ballycastle will bring heavy rain from the cumulonimbus clouds. The next point I would make reference to is the wind speed. There are 45 knots of wind speed in Ballycastle, whereas there are 10 knots of wind speed in Limerick. This is because the isobars are close together in Ballycastle, whereas they are spread further apart in Limerick. My final point for my 5th mark will be temperature. It is 8 degrees in Ballycastle, whereas it is 4 degrees in Limerick. This is because Limerick is in the cold air sector, whereas Ballycastle is in the warm air sector. And that would be us completed that question at that point. Now again, that question is a little bit different to some of the ones we studied previously or some of the questions you may have heard of. But that is just how we apply our knowledge of a depression. So we use our table, we apply our knowledge, and we're able to get 5 marks in a question like that. Now this brings us to the end of our weather revision. Hopefully you found it useful. If you have any further questions, please ask your teacher.